Hello learners, welcome to NIOS Studio. I, Dr. Gargi Kaur Majumdar from Delhi University, would like to present this session on pressure and wind. Now let's have a look at the objective of the session. To explain air pressure and its measurement, to understand the distribution pattern of air pressure, to study about the factors impacting distribution of air pressure, then to establish relationship between the temperature and other factors in existence of pressure belts, to explain the seasonal distribution of pressure, to establish the relationship between pressure gradient and speed of wind, to discuss about different types of wind and cyclones. Now let's begin with air pressure and its measurement. The atmosphere is held on the earth by gravitational pull of the earth. The column of air exerts weight in terms of pressure on the surface of the earth. The weight of the column of air at a given place and time is called air pressure or atmospheric pressure. Atmospheric pressure is measured by an instrument called barometer. It is measured as force per unit area. The unit used for measuring pressure is called millibar, or in short form MB. 1 millibar is equal to the force of 1 gram per square centimeter approximately. A pressure of 1000 millibars is equal to the weight of 1.053 kilograms per square centimeter at sea level. The mean atmospheric pressure at sea level is 1013.25 millibars. Now let's understand the distribution of air pressure. Distribution of atmospheric pressure on the surface of the earth is not uniform. It varies both vertically and horizontally. Air is highly compressible. As it compresses, its density increases. The higher density of air, the greater is the air pressure, and vice versa. The lower layers of the atmosphere have higher density, hence exert more pressure. Conversely, the higher layers are less compressed and hence they have low density and low pressure. Now let's understand the vertical distribution of air pressure. Air pressure also decreases with increase in altitude, but it does not always decrease at the same rate. The normal rate of decrease in air pressure is 34 millibars per every 300 meters increase in altitude. The columnar distribution of atmospheric pressure is known as vertical distribution of pressure. Temperature of the air, amount of water vapor present in the air, and gravitational pull of the earth determine the air pressure of a given place at a given time. This is a pictorial representation of the vertical distribution. Since these factors are variable with change in height, there is a variation in the rate of decrease in air pressure with increase in altitude. The effects of low pressure are more clearly experienced by the people living in the hilly areas as compared to those who live in plains. Now let's understand the horizontal distribution. The distribution of atmospheric pressure over the globe is known as horizontal distribution of pressure. It is shown on the maps with the help of isobars. An isobar is a line connecting points that have equal values of pressure. The spacing of isobars expresses the rate and the direction of change in air pressure. This change in air pressure is referred to pressure gradient. Pressure gradient is the ratio between pressure difference and the actual horizontal distance between 2 points. Close spacing of isobars expresses steep pressure gradient while wide spacing indicates gentle pressure gradient. The horizontal distribution of atmospheric pressure is not uniform in the world. It varies from time to time at a given place. It varies from place to place over short distances. The factors responsible for variation in the horizontal distribution of pressure are as follows: air temperature, the Earth's rotation, pressure of water vapor. Now let's study the factors. First, the air temperature. The fundamental rule about gases is that when they are heated, they become less dense and expand in volume and rise. Hence, air pressure is low in equatorial region and it is higher in polar regions. Along the equator lies a belt of low pressure known as the equatorial low or doldrums. The low air pressure in the equatorial region is due to the fact that hot air ascends there with gradual decrease in temperature causing thinness of air on the surface. In polar region, cold air is very dense, hence it descends and pressure increases. Other factor is Earth rotation. The Earth's rotation generates centrifugal force. This results in the deflection of air from its original place, causing decrease of pressure. It is believed that the low pressure belts of the subpolar region and the high pressure belts of the subtropical regions are created as a result of the Earth's rotation. The Earth rotation also causes convergence and divergence of moving air. Areas of convergence experiences low pressure, while those of divergence have higher pressure. Another factor is the pressure of water vapor. Air with higher quantity of water vapor has lower pressure, and that with lower quantity of water vapor has higher pressure. In winter, the continents are relatively cool and tend to develop high pressure centers. In summer, they stay warmer than the oceans and tend to be dominated by low pressure. Conversely, the oceans are associated with low pressure in winter and high pressure in summer. Now let's do a quick recap. An isobar is a line connecting points that have equal values of pressure. Pressure gradient is the ratio between the pressure difference and horizontal distance between 2 points. On an average, air pressure decreases by 34 millibars per 300 meters increase in the height. Now let's study the pressure belts. Horizontal distribution of air pressure across the latitude is characterized by high or low pressure belts. These pressure belts are the equatorial low pressure belt, the subtropic high pressure belts, the subpolar low pressure belts, the polar high pressure belts. Now let's have a look at the diagram of pressure belt. Now let's discuss this equatorial low pressure belt at first. The sun shines almost vertically on the equator throughout the year. As a result, the air gets warm and rises over the equatorial region and produces equatorial low pressure. This belt extends from equator to 10 degrees north and 10 degrees south latitude. Due to excessive heating, horizontal movement of air, wind is absent here. This belt is called doldrums, the zone of calm. This belt is also known as Intertropical Convergence Zone, which is ITCZ, due to convergence of winds flowing from subtropical high pressure belt. Now the subtropic high pressure belt extends from tropics to about 35 degree latitudes in both the hemisphere. The existence of these pressure belts is due to the fact that the uprising air of the equatorial region is deflected towards pole due to the Earth's rotation. After becoming cold and heavy, it descends in these regions and gets piled up. This results in high pressure. Calm conditions with feeble and variable winds are found here. Now let's discuss the subpolar low pressure belt. The subpolar low pressure belt extends between 45 degree north and the Arctic Circle in the northern hemisphere and between 45 degrees south and the Antarctic Circle in the southern hemisphere. They are known as the north subpolar low and the south subpolar low pressure belt respectively. Winds coming from the subtropical and the polar high belts converge here to produce cyclonic storms or low pressure condition. This zone of convergence is also known as polar front. Now, the final belt is the polar high pressure belt. In polar regions, sun never shines vertically. Sun rays are always slanting here, resulting in low temperature. Because of low temperature, air compresses and its density increases. Hence, high pressure is found here. In the northern hemisphere, the belt is called the North Polar High Pressure Belt, while it is known as the South Polar High Pressure Belt in the southern hemisphere. Now, let's have a look at the important points to remember, which is subtropical high pressure belts are called horse latitude. Convergence of subtropical and polar wind result in the formation of cyclones in the subpolar regions. The location of the pressure belt is not permanent. They shift northward in July and southward in January, following the changing position of the sun's direct rays as they migrate between the tropics of Cancer and Capricorn. High pressure belts are dry while low pressure belts are humid. Now let's study the seasonal distribution of pressure. The variation of pressure from place to place and from season to season over the earth plays an important role in affecting the weather and climate. In January, with the southward apparent movement of the sun, the equatorial low pressure belt shifts little south of the mean equatorial position. Areas of lowest pressure occurs in South America, Southern Africa and Australia. This is because the land tends to get hotter rapidly than water. Let's have a look at the distribution of air pressure. This is in the month of January. This is due to the fact that land cools more rapidly than oceans. The temperatures are lower in winter than the surrounding seas. In the southern hemisphere, the subpolar low pressure belt circles the earth as a real belt of low pressure and is not divided into cells because there is virtually no landmass. In northern hemisphere, two cells of low pressure, namely Iceland low and Aleutian low, develop over the North Atlantic and North Pacific Oceans respectively. In January, the subtropical high pressure cells are centered over the ocean in the southern hemisphere. The belt of high pressure is interrupted by the continental landmasses where the temperature is much higher. In the northern hemisphere, ridges of higher pressure occurs in the subtropical latitudes over the continent. A well-developed high-pressure cell occur in the interior parts of Eurasia. Now, let's have a look at the distribution of air pressure in the month of July. In July, the equatorial low-pressure belt shifts little north of the mean equatorial position because of the northward apparent movement of the sun. All the pressure belts shift northward in July. The Aleutian and Icelandic lows disappear from the oceans while the land masses which developed high pressure during winter months have extensive low pressure cells now. In Asia, a low pressure develops. The subtropical highs of the northern hemisphere are more developed over the oceans Pacific and Atlantic. In the southern hemisphere, the subtropical high pressure belt is continuous. Subpolar low forms a continuous belt in the southern hemisphere while in the northern hemisphere there is only a faint oceanic low. Now let's discuss wind. Air attempts to balance the uneven distribution of pressure. Hence, it moves from high pressure areas to low pressure areas. This horizontal movement of air in response to difference in pressure is termed as wind, while vertical or nearly vertical moving air is called air current. Both winds and air currents form the system of circulation in the atmosphere. What are pressure gradients and winds? There is a close relationship between the pressure and the wind speed. The greater the difference in air pressure between the 2 points, the steeper is the pressure gradient and greater is the speed of the wind. The gentler the pressure gradient, slower is the speed of the wind. As you can also look at this diagrammatic representation of pressure gradient. The Coriolis effect and wind. Winds do not cross the isobars at right angles as the pressure gradient directs. They get deflected from their original paths. One of the most potent influences on wind direction is the deflection caused by the Earth's rotation on its axis, known as the Coriolis effect or Coriolis force. The Coriolis force tends to deflect the winds from their original direction. In northern hemisphere, winds are deflected towards their right and in the southern hemisphere towards their left. This is known as Ferrel's law. The Coriolis force is absent along the equator but increases progressively towards the poles. Now, have a look at the deflection by winds by Coriolis force. Now, what are the types of winds? Winds are generalized under three categories: planetary winds or permanent winds, periodic winds or monsoonal winds, local winds, including hot and cold wind. What are planetary winds? Planetary or permanent winds blow from high pressure belt to low pressure belt in the same direction throughout the year. They blow over vast area, continents and ocean. They are easterly and westerlies and polar easterlies. What are easterlies? The winds that blow from subtropical high pressure areas towards equatorial low pressure areas called trade or easterly winds. Because of the Coriolis effect, the northern trade winds move away from the subtropical high in the northeast direction. In southern hemisphere, the trade winds diverge out of the subtropical high towards the equatorial low from the southeast direction. As the trade winds tend to blow mainly from the east, they are also known as the tropical easterlies. Now, what are westerlies and polar easterlies? The winds that move poleward from the subtropical high pressure in the northern hemisphere are detected to the right and thus blow from the southwest. Rather, are deflected to the right and thus blow from the southwest. These in the southern hemisphere are deflected to the left and blow from the northwest. Thus, these winds are called westerlies. Polar easterlies blow from polar regions towards subpolar low pressure regions. Their direction in the northern hemisphere is from northeast to southwest and from southeast to northwest in southern hemisphere. Now, what are periodic winds? The direction of these winds changes with the change of season. Monsoon winds are the most important periodic winds. The word monsoon has been derived from the Arabic word mawsim, meaning season. The winds that reverse the direction with the change of seasons are called monsoon winds. During summer, the monsoon winds blow from sea towards land and during winter from land towards seas. Traditionally, these winds are explained as land and sea breezes on a large scale. Nowadays, the monsoon is generally accepted as seasonal modification of the general planetary wind system. The Asiatic monsoon is the result of interaction of both planetary wind system and regional factors, both at the surface and in the upper troposphere. India, Pakistan, Bangladesh, Myanmar, Sri Lanka, the Arabian Sea, the Bay of Bengal, Southeast Asia, North Australia, China and Japan are important regions where monsoon winds are prevalent. And what are local winds? Local winds usually affect small areas. They are confined to the lower levels of the troposphere. This is a representation of sea and land bridge. Land and sea bridges are prevalent on the narrow strips along the coast or a lake. It is a diurnal or daily cycle in which the differential heating of land and water produces low and high pressures. During the day, when the landmass gets heated more quickly than the adjoining sea or large lake, air expands and rises. This process produces a local low pressure area on land. Sea breeze then develops, blowing from the water, that is from high pressure area, towards land, which is the low pressure area. The sea breeze begins to develop shortly before noon and generally reaches its greatest intensity during midday to late afternoon. These cool winds have a significant moderating influence in coastal areas. At night, the land and the air above it cools more quickly than the nearby water body. As a result, land has high pressure while the sea has comparatively a low pressure area. Gentle wind begins to blow from land, which is a high pressure, towards sea, again the low pressure region. This is known as land breeze. What are then the mountain and valley bridges? This is another combination of local winds that undergoes a daily reversal consists of the mountain and the valley bridge. On a warm sunny day, the mountain slopes are heated more than the valley floor. Hence, the pressure is low over the slopes while it is comparatively high in the valleys below. As a result, gentle wind begins to blow from valley towards the slope and it assumes the name of valley bridge. After sunset, the rapid radiation takes place on the mountain slopes. Here, high pressure develops more rapidly than on the valley floor. Cold, arid, heavy air of mountain slope starts moving down the valley floor. This is known as the mountain breeze. Now, what is hot winds? We know about Lu, Fohn and Chinook. These are important hot winds of local category. Lu are hot and dry winds which blow very strongly over the northern plains of India and Pakistan in the month of May and June. We all experience that in summer. The direction is from west to east and they are usually experienced in the afternoons. The temperature varies between 45 degrees centigrade to 50 degrees centigrade. And what is Fohn? Fohn is strong, dusty, dry and warm local winds which develops on the leeward side of the Alp mountain ranges. Regional pressure gradient forces the air to ascend and cross the barrier. Ascending air sometimes causes precipitation on the windward side of the mountains. After crossing the mountain crest, the Fohn winds start descending on the leeward side or northern slopes of the mountain as warm and dry wind. The temperature of the winds vary from 15 degrees centigrade to 20 degrees centigrade, which helps in melting snow. thus making pasture land ready for animal grazing and helps the grapes to ripe early. And what is the Chinook? Chinook is the name of hot and dry local wind which moves down the eastern slope of the Rockies in USA and Canada. The literal meaning of Chinook is snow eater, as they help in melting the snow earlier. They keep the grassland clear of snow, hence they are very helpful to ranchers. Cold winds, which is mistrals. The local cold winds originate in the snow-capped mountains during winter and move down the slope towards the valley. They are known by different names in different areas. Mistrals are most common local cold winds. They originate on the Alps and moves over France towards the Mediterranean Sea through the Rhone Valley. They are very cold, dry and high velocity winds. They break down temperature below freezing point in areas of their influence. People in these areas protect their orchards and gardens by growing thick hedges and build their houses facing the Mediterranean Sea. Now let's understand air mass. An air mass is an extensive portion of the atmosphere having uniform characteristics of temperature, pressure and moisture which are relatively homogeneous horizontally. An air mass develops when the air over a vast and relatively uniform land or ocean surface remains stationary for a long time to acquire the temperature or moisture from the surface. The major source regions of the air masses are the high latitude, polar or low latitude tropical regions having such homogeneous conditions. Air mass therefore are of two kinds, polar and tropical air mass. Polar air mass is cold and tropical air mass is warm. When cold air mass and warm air mass blows against each other, the boundary line of convergence separating the two air masses is termed as front. When the warm air mass moves upward over the cold air mass, the front formed in such a situation is called warm front. On the contrary, when the cold air mass advances faster and undercuts the warm air mass and forces the warm air upwards, the front is called as the cold front. The frontal surface of cold front is steeper than that of a warm front. A prevailing air mass in any region, polar, tropical, maritime or continental, largely controls the region's general weather. Now let's have a look at cyclones, tropical and temperate. Cyclones are elliptical arrangement of isobars having low pressure at the center with a convergence of winds within them. The wind direction in the cyclone is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Cyclones are of two types, the temperate and tropical. Now, what are the movement of wind associated with cyclones and anticyclones in northern and southern hemisphere? You can have a look at this picture for the same. And what is temperate cyclone? Temperate cyclones are formed along a front in mid-latitude between 35 degree and 65 degree north and south. They are generally extensive, having a thickness of 9 to 11 kilometers. They blow from west to east and are more pronounced in winter season. Atlantic Ocean and Northwest Europe are major regions of temperate cyclones. Each cyclone alternates with a high-pressure anticyclone. The weather associated with the cyclone is drizzling rain and of cloudy nature for a number of days. The anticyclone weather is sunny, calm and of cold waves. This map shows the track of the cyclones. Now, what is a tropical cyclone? Tropical cyclones are formed along the zone of confluence of northeast and southeast trade winds. This zone is known as the intertropical convergence zone. Cyclones generally occur in Mexico, southwestern and North Pacific Ocean, North Indian Ocean and South Pacific Ocean. These cyclones differ from temperate cyclones in many ways. There are no clear warm and cold front as temperate seldom differs in intertropical convergence zone, as temperature seldom differs in intertropical convergence zone. They do not have well-defined patterns of winds and are energized by conventional currents within them. Generally, these are shallow depressions and the velocity of winds is weak. These are not accompanied by anticyclones. The arrangement of isobars is almost circular. These are not extensive and have the diameter of about 160 to 650 km. Few of them become very violent and cause destruction in the regions of their influence, which is often on the coast. However, about 8 to 48 kilometer area around their center is called the eye of these stormy cyclones remains calm and rainless. If this eye is detected, it is possible for the modern science to stop further development of these strong cyclones. They are called hurricanes in the Caribbean Sea, typhoons in China, Japan and Philippines, cyclones in the Indian Ocean and willy-willies in northern Australia. Now let's have a quick recap. Atmospheric pressure is the weight of the column of air at a given place and time. It is measured by an instrument called barometer and unit of measurement of pressure is millibar. The distribution of atmospheric pressure varies both vertically and horizontally. It is shown on the maps through isobars, which are the imaginary lines joining the places having equal air pressure. In high latitudes, the atmospheric pressure is more than the pressure at low latitude. The zonal character of horizontal pressure is commonly known as pressure belts. There are 4 pressure belts spread over the earth. They are equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt and the polar highs. Thermal factor causes differences in pressure. Pressure belts are not fixed. They shift northwards in summer and southwards in winter with the apparent movement of the sun. Pressure gradient is the difference in horizontal pressure between regions of high pressure and regions of low pressure. The difference in air pressure causes movement of air called wind. There are wind systems that blow regularly on a daily pattern. Examples include the land and the sea bridges, the mountain and valley bridges, and winds formed as a result of compression. There is a close relationship between pressure gradient and wind speed. Due to Coriolis force, winds deflect from their original course. Winds are grouped under planetary, periodic and local winds. Planetary winds blow in the same direction throughout the year, while the other types of winds get modified due to certain reasons. Air masses are horizontal large bodies of air which have uniform temperatures and moisture contents. The boundary line between two different air masses is called a front. Air masses and front causes temperate cyclones in mid-latitudes, and another type of cyclones are the tropical cyclones, which originate on tropical oceans and influence the coastal areas. Sometimes they turn violent and cause heavy loss to life and property. Thank you, listeners. Hope this session was fruitful and thank you for listening patiently. Good luck.